Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to talk about another method of dealing with classification called standard deviation. So to recap where we left off so far, we've talked about equal interval, which divided it so that each class had a same range based on the number of classes. We talked about quantile, where each class had the same number of observations based on the number of classes. And now we're going to talk about this idea of standard deviation, which is a slight bit different from what we talked about before. So let's go ahead and talk about standard deviation. So the way that standard deviation works is it's involving the mean, or x bar that we talked about before, and the standard deviation, or that sigma that we talked about before. So mean and standard deviation. Mean and standard deviation. And what I want to do is I want to explain this approach conceptually before we get into actually calculating anything or showing it equation-wise. So the idea here is if we have a number line something like this with our min and our max, right? And then somewhere, hopefully towards the center, we have the mean of the data set, right? So the idea here is that we calculate the standard deviation using the same standard deviation equations that we've talked about before. But what we do is we use the standard deviation, or some portion of the standard deviation, to be equal to the range. So in this case, the range of each class. Oh, let's go ahead and undo that and do white. Right, in this case, the range of each class is some portion of the standard deviation. Right, now I'm going to explain how ArcGIS Pro implements it, because it is implemented differently depending on what software you're using. But the way that ArcGIS Pro processes this is it's going to have the data centered on the mean, and it's going to go out from the mean some portion of the standard deviation. So let's say that we were going to do, let's say maybe half the standard deviation per class, right? So what it's going to do is it's going to center on the mean, and I'm going to use blue here as my breakpoints. So it's going to go like this and like this, right? So centered on the mean, right? So this is going to be, so it's going to go like this. This would be one class. This would also consist of half a standard deviation, right? So this breakpoint right here, this breakpoint right here would be x bar minus 1/4 of the standard deviation, right? And this breakpoint right here would be x bar plus 1/4 of the standard deviation. So that the entire width here is 1/2 of the standard deviation centered around the mean. And then what we would do is we would then go this way over here. We would go to here, right? And then this would be another class whose width is half a standard deviation, right? So this would then be x bar plus, so it would be 1/4 plus 1/2, so this would be 3/4 of the standard deviation, right? So that this distance from here to here is a half a standard deviation. And then we would do the same thing over here. Right, this would be another class, which would also be a half a standard deviation wide. But this would then be this bar breakpoint right here would be the mean minus 3/4 of a standard deviation, right? So hopefully this makes sense. So let's go ahead and try to figure out how we would implement this in practice, given that the idea is we have the mean at the center, and then we're going some amount of standard deviations away from the mean. So let's go ahead and pop up our Excel sheet here. We're going to copy the stuff that we were working on last time. And we're going to look at standard deviation. So some things we need to know. We need to know the standard deviation, which we actually calculated in the previous set of videos, which we have actually right here. This was our variance and standard deviation example. So we're going to pull that standard deviation, that 0.84. And then we need to pull the mean also. So we're going to pull back over a couple of videos to where we grabbed the average of the data set, which was 5.53. So we will come back over here and we have the mean at 5.53. Okay. So if we want to have our if we wanted to have our 3 classes based on the standard deviation, our first class, let's keep this simple and we'll do 1 standard deviation width. So width equals 1 SD, and we're looking for 3 classes. So what we're going to end up having to do here is we're going to end up having 1 class be the median, or the mean. So we're going to have the mean for class 2 because we want the middle class to be the mean plus a half a standard deviation and the mean minus half a standard deviation. So the lower end of the middle class is going to be equal to 5.53 minus, and then we want the standard deviation divided by 2 because we want the full width to be 1 standard deviation. So that's going to be minus 0.42. So our lower bound for class 1 is going to be 5.11, and the upper bound is going to be equal to the mean plus half a standard deviation, or 0.42, to 5.95. Okay. So now, unfortunately, because we want 3 classes, we have to include the lower bound here. So this is going to be 4.3 to 5.1, and this is going to be 5.11 to 5.95, and then the third class is going to be 5.95 to 6.8. So you can see that in this case, standard deviation actually mirrors pretty closely equal interval in the sense that these 2 data points are going to go into class 2. But you can see how we set up the middle class, at least because we only had 3 classes, that the middle class was based on 1 standard deviation centered in the mean, and then the other 2 classes, because we only had 3, had to include the minimum value of the data set and the maximum value of the data set. Hopefully this makes sense. I know this one's probably a little more complicated, especially when we start to include more data and larger and greater number of classes. But hopefully, at least in the simplistic scale, the way we approached it made sense. Again, centering on the mean and based on the standard deviation. Hopefully this makes sense, and if you have any questions, please reach out. Thank you.